And we have guidelines for formulation of LPP. What we should follow when we are trying to formulate a problem. We have that should be done in two phases. In phase 1, we have verbal description without ambiguity. That means there should be complete clarity when we are formulating, because formulation of the problem is very, very important, because that will become basis for solution. Because further steps, whatever we do, they all depend upon, or we are carrying out work on these things. So description should be without any kind of confusion. There should be complete clarity. And then what is the objective within a given situation, or whatever the situation is presented to us, we should try to find out what is the objective, overall objective out of that situation we are aiming at. Then we should identify the factors or constraints. As we have discussed, the limitations are known as constraints that should be taken into consideration. Then in phase 2, we have to identify what are the variables that are relevant to the problem, which will have more impact on the problem. That is what, first of all, we need to do in the phase 2. Then what is the contribution by each of the coefficients? For example, if an organization is producing 3 kinds of products, the profit for each of the product is given. What is the contribution by each of that unit we need to understand. Then formulate the objective function. As we have discussed, maximizing or minimizing. Minimizing is relevant in some context, maximization is relevant in some context. We have to identify that and write down the objective function. Then we need to identify what are the available resources, what is the limitation, and what is the restriction, or what is the constraint we have, we need to understand. Then we have to represent all these things in a mathematical form, mathematical restriction. And we'll see we have objective function at the top, and then we'll write down subject to the constraint. That means we have to take all these constraints into consideration, and either we should maximize or minimize that objective function as required. So usually these constraints are always expressed as less than or greater than. For example, market demand. There is a certain demand for that particular product, minimum number of units that have to be produced, or maximum number of units that have to be produced, maximum availability of material, maximum number of hours available. Likewise we see. And similarly, at the end, we should necessarily mention that non-negativity condition. It is essential in linear programming problem, because as we have seen, there are no negative values that the variables can assume in LPP.